Okay, today we're going to talk about FlexGate. Now, many of you guys already know what FlexGate is, but to those that don't, what FlexGate is, FlexGate refers to a design flaw on 2016 and 2017 MacBook Pros. Now, Apple only officially acknowledges the 13-inch MacBook Pros made in 2016 to have this issue, but that is false. So, 2017 machines are just as commonly affected, and the 15 inches are also just as commonly affected, but Apple won't admit that. So the 15 inches actually have the same flex cable length, everything, compared to the 13 inches, and the 2017 machines are pretty much unchanged other than a few processor just processor options. You know, they have a newer generation CPU, so otherwise they're pretty much an identical machine. So here we have a 15-inch MacBook Pro that came in with the complaint of no backlight. So if we plug this in, we're going to notice something here. We're going to tilt our MacBook just so it's barely just open here, right? It's going to turn on here in a second. Might take a minute. I might actually have to hit the power button here. So we're going to watch this, okay? Give it a minute to boot. Have trackpad click, and we're going to see an Apple logo and a screen pop up in there. Yep, there's that Apple logo. Let's just wait so you can see it. Okay, so I have my background, right? I'm going to tilt it up, and our screen shuts off, right? This is typical of FlexGate. So typically with FlexGate, your screen will look totally black like this, and then you open it, or if you have it just open at about a 45-degree angle, you'll see backlight. You open it, and it's gone. So let's go ahead and understand what happens here. So let's go under the microscope, and let me show you what the actual fault is. All right, here's our display flex cable. Now our display flex cable is... this is one of many display flex cables. So this particular flex cable here is our backlight. This is going to be our culprit right here. We have a LCD data line right here. This is responsible for putting an image on your screen. Okay, everything on your screen will go through there. That's all data received from the graphics processor, either in the CPU or the dedicated GPU. Another data cable right here. Here we have our webcam connector. So this is purely for our camera and our ambient light sensor. Here we have our flex cable that connects our screen to our system board. But the one that we're going to be concerned about today is this guy right here. This is the one that fails, okay? And if we look at this, okay, this cable actually moves when the display opens. All right, so this is too short, and what ends up happening is it gets cracks in it. And if we look really closely here, we can actually see the crack right there. So this is something that you won't usually see with the naked eye, but there's a crack right there, okay? And there's traces, there's electrical lines running through this, and when it gets cracked, you'll lose a connection there when it opens fully. Now let's open this MacBook fully, and let's see what it looks like when it's open pretty much all the way. So let me get my microscope over here. I'm going to move the MacBook over so you can see this. All right, look at that. So this is with our screen fully open. Okay, see that? It moves, and look at that stress that it puts on that cable. So this is open all the way. And look at this. It's. I can see if I can tilt this so you guys can see it. But that is a very visible crack and a fatigue point right there. Okay. Could even peel off a little bit of the conformal coating on that connector. Now our webcam, same thing. Our webcam is under stress. This is what it should look like, but it just doesn't happen on the webcam for some reason. I don't know why. Same length cable, but it just doesn't happen. Okay, you can see the difference of what it's supposed to look like and how this looks like. So that's what FlexGate is. It is tears in this cable from fatigue over time, from the opening and closing the lid. Eventually, it results in black screen and no backlight. Now, there's a couple ways that you can fix this. So let's talk about that. So option one is replace the screen. This is what Apple is going to do. They're going to replace it with a brand new screen, and it's going to work. But the problem is that new screen, whether it's a 2016 or 17 or a replacement from Apple, is still going to develop the same issue. It's the same screen. It still has the same defective flex cable, and it's going to happen again. So you get your screen replaced. I mean, this is about a $700 screen. So this screen right here is $700. You get that replaced by either Apple or an independent repair shop, and then a year later, 2 years later, 3 years later, you'll have the same issue because it doesn't fix the design flaw. The second way to fix this is by wires. You will see a lot of people run wires across the cable. They'll basically cut out the cable, run wires over to the screen board. I've done it, okay. I had a couple of returns. It wasn't anything drastic. It wasn't like all of them came back, but there was a couple of returns, and the reason why is the wire repair is most likely totally fine for people that open their laptops normally. So normally you have a laptop, right? You open it like this, all good. Well, the thing is, people don't open their laptops like that. They open their laptops like this, right? They slam it open and they let it kind of bounce off the hinges there. And with that, what happens there is it stretches those wires just like it stretches the original flex cable, and over time they break. That's the way to fix it. Third way to fix it is by replacing, or not really replacing, but splicing the flex cable and extending its length, which is what we're going to do here in a minute here. So what we are going to do, we are going to cut this flex cable at the base of the screen. Not at the base, right at the hinge assembly, right? Okay, we're going to cut this right at the hinge assembly, and then we're going to get another flex cable off of another display. So here we replace screens all the time. You know, we have a big stock of A1708, A1707 displays that they're all the same flex cable. That they're totally fine. I mean, there's no cracks in these flex cables. They're just off of screens that have been, you know, dropped or something that have cracks in them. But the flex cable is totally fine, so that's why we kind of recycle these cables. What we're going to do is we're going to cut it at the base of that display, okay? And then we're going to splice it onto the existing flex cable on this device. And what's going to happen is it's going to extend this flex cable about a centimeter. And what that's going to do is, one, it's going to extend the flex cable so it's not under so much stress, but it's also going to move the point of maximum stress on the cable from that little bend right there to under the antenna bar, which is right on the top of this device, which is going to be the thickest and strongest part of the cable, since it's going to be dual layered and it's going to be coated with conformal coating. So we're going to do that now. First things first, I got to get this display off this laptop. So it's a pretty easy process to remove this display. We just have a series of screws. There's a few screws in the antenna bar. There's our hinge screws, and there's our screws on our T-con board here. So let's just fast forward through that and get going. Screen is off the laptop and on our bench here. I'm just going to remove this little shield on the display flex cable here. So just this right here, there's two screws in it. Really easy to get to. I'm going to move my microscope out of the way because that's restricting me from putting my screwdriver right there. And then here's our flex cable. Now this is just a connector here. We're going to unplug this in a second here, but I want to make my cut. And I am going to cut this cable with an X-Acto knife, a really sharp X-Acto knife. And I'm going to make this cut right at the hinge base right here. So we're going to get our X-Acto knife now. You won't really scratch this at all if you do it in this method, but if you do, it's not a big deal because this is not in a visible portion of the screen, and if you do scratch it, it's right at the seam here, so it's not visible at all. And so I'm just going to score this with my X-Acto knife here. We're just going to move it back and forth, and you'll feel it when it's cut fully. It's not quite there yet. I think we're good. Nope, not yet. Not quite. Use a little bit of pressure here too. There. Almost. There. That is a clean cut. Now this right here, we are going to get rid of. So we do not need this. This is the old flex cable. Okay. It's cut right at the base. So we don't need this anymore, so we're going to get rid of this. And let's go harvest our new flex cable from a different display. Alright, here's our donor display. If you do not have a donor display to take the cable off of, you can buy these cables new usually as well. It's not really necessary. We just want to make sure there's no obvious damage with the flex cable. If there's no fatigue cracks, if the flex cable is designed in the proper length, I should say, and there's no fatigue cracks, the chances of a flex cable failing over time are close to nothing. So I'm just inspecting this cable right here. You can see that it's totally fine. There's no fatigue cracks. I'm using a little bit of pressure. Totally fine. That seam right there is normal. So if you remember, on the first cable, I cut it right about here. All right. Now on this one, I'm actually going to cut it down here. Okay. So I'm going to cut it right down here. Now this is a donor display. I don't care what happens to this. I'm just going to mark it. I'm going to use, I could just use my X-Acto knife too. There's that. I was going to say use scissors, the special type of scissors, but that's fine. So here's our flex cable. It's longer. And that extra bit of length there is going to be what's going to prevent our screen from failing down the line again. Alright, now we need to prep this cable for soldering, so we need to do a few things with this. So I just want to secure this to my bench in the meantime, so I'm going to use a little bit of Captain tape. If you don't know what Captain tape is, it's this high temperature, high tensile strength yellow tape that is really, really strong. We use it for many applications in electronics, but in this case we are just going to use it to secure this cable to our bench. Actually go a little bit down here. So I'm actually going to put this right at the point where I'm going to scrape off. So I'm going to scrape off all the coating on this cable. Now if we look at this, you can tell that there is a coating on this cable. We can't see electrical connection here because there's this black coating surrounding it. Now how I'm going to do this is I'm going to be gentle but firm would be how I'm going to describe this. So I want to get this coating off, but I don't want to damage the underlying flex. So I'm just going to scrape real gentle. We're going to deform the cable a little bit, that's a given. But I kind of just want to, once we get some of this off, it'll be a lot easier. So I'm just really gently but firmly scraping off this coating, and you'll see we make progress on it, and we will start to see the underlying cable. I don't want to go too much. I do not want to break any of these connections here. So this is copper here. You can see it's a little bit lighter. This is copper. There's a little layer of adhesive over that copper as well. We're not going to worry about that. We'll take that off with our soldering iron. Now these thick traces right here, this is all one trace and this is all one trace. This is going to be my primary fastener to the other cable, so I want to make sure all of this coating is off of that. I don't want any little bit at the end. Just like that. That's perfect. Little speck on these guys is okay, but I want to get as much off of it as I can. I don't have to worry about anything up there. That's clean. That's sufficient for our purpose there. So now what I need to do is I'm going to clean this off a little bit. A little bit of alcohol. Just to get the debris off. Just like that. Then I'm going to get a little bit of flux. Put it on here. And then I'm going to get my iron. Now, I'm going to use a different temperature on this compared to what I would use if, let's say, I'm soldering on a thick board. So I'm going to use 540 degrees because this flex cable is very, very thin and we do not need much heat. I want to get some solder on these pins. And what we're also going to do by this is we are going to take off this coating on this cable. So that's what I'm going to kind of use my iron for first. You can see that coating comes off and we could put some solder on it. And so that's what my goal is here. I'm being gentle. If you push on this flex with heat, you will ruin it. So I'm just gently using my iron to take this coating off. The cable's going to bend and warp a little bit. That's normal. Don't panic. That's sufficient. Have some bridges there, but bridges are really easy to resolve. We're just going to do flux one more time. And take care of that. That is beautiful. I want purposefully big solder blobs on these big traces right there. You'll see why in a second there, but that is otherwise sufficient. Let's clean up this flux. This time around I want the cable to be pristine, so I'm going to use some acetone. Acetone is a bit better at dissolving flux than isopropanol. Just like that. That is clean. So this is ready. I'm going to pull this off of here. Let's clean this again. Alright, now let's grab our screen and do our screen side of the cable. Now, that doesn't look too good, does it? Looks like it's full of dust and crumbs and stuff. So let's clean this up. So, because I'm going to have to tape this cable down, and tape really doesn't like sticking to something that looks like that. So we're going to kind of make a nice surface to tape this down to. Just like that. Now where I'm going to put my piece of tape is going to be right there. So right on that hinge. So I'm going to grab a little piece, another piece of Captain tape, this time with a little bit of a different width. So if you repair electronics, you probably have multiple rolls of this stuff. If not, get multiple rolls of this stuff. Captain tape, that is. And I am going to hold this like it's probably going to be hard to get on camera here. Let me zoom out. I'm going to hold that like this and put my piece of tape along the hinge there. Okay, look at that. That's what I want right there. Now this is arguably the hardest part of the repair right here, because it's really easy to screw up if you're not careful. So we're going to do the same thing. We're going to scrape off this coating. Remember, there's coating on this cable. So I'm just going to, same process, gently score this up and scrape it away. It's trickier because we don't have a nice surface. We're right on the screen. It's a lot easier to nick this cable right here and cause damage to it. So the main thing here, take our time, we're in no hurry. We'll zoom in a little bit. I'm using a lot gentler pressure than I was on the other cable, because it's really easy to snag it. See how it kind of just snagged right there, and it'll dig into the cable and ruin it, so that's not what we want. Kind of use my blade lengthwise, really gently. I cannot put emphasis on that enough. Just kind of sliding my blade along the connector, and I'm literally using no pressure. If I use pressure on this cable would fall apart. So I'm just letting the blade do the work. And slowly taking this coating off. If you feel it wants to snag, see how there's resistance, immediately stop, pull back. Because if you ruin this cable on the screen, there's no coming back from that usually. Could always grab another replacement cable, but this one is attached to the screen. And good luck. Kind of want to purposely screw up to show you guys, but I don't want to do that. I want to. What's really common is you'll cut it like right here. There'll be a nudge out where you could still come back from it, but it's harder. But I think I'll do a separate video on that if I get a request to about how to correct that if that does happen. want to make sure I have a really clean surface on the end here, because that's where we're going to have active solder connections. I'm not too concerned if there's like residual up here because I'm not going to be soldering up there, but this is the nice surface that I want to have right here. If you feel like your area is being too crowded with debris, clean. So I noticed there's some debris here, so I just want to clean up and get this stuff out of here so I can continue. Use your fingernail or tweezers. Sometimes using your fingernail has benefits. You can kind of keep the cable steadier with more pressure. Don't cut your finger though. I'm not responsible if you cut off your finger. Put that out there. And I'm happy with that. That's sufficient. That's a sufficient soldering surface. So, again, you can probably guess what's next. We got to get this adhesive off of here. A little bit of flux. Now definitely hold it with tweezers because you don't want to burn yourself. You're not going to melt anything here. This is aluminum, so that's totally fine to use heat there. Get a little bit more solder here. And get a nice tin on all of these. A little bit more flux just to finalize it, and that looks pretty good. Alright, that's that. We got to clean up, and then we are going to splice our cable. Sometimes it helps after you're done using this much flux to change your tape too, if it's necessary. It's kind of lifting there. I could get away with it, but just wanted to put that out there. If you need to, go ahead and do it. Doesn't have to be super clean in this step. I just don't want gobs of flux there. Let's grab our cable, and here's our jig that we have to give a little support. You could use anything. It just helps to have the cable at separate length there. And now what I'm going to do, okay, look at this. See that? The cable matches. I'm going to slide this like this, okay? This is where it starts getting a little bit tricky because you have to align it. And I want some overlap in that cable there. It doesn't have to be a lot, but I do want some overlap. Alright, like that. That should be sufficient. Now, this is probably the tricky part. We have to tack this down, and we don't want to burn ourselves or anything like that. So this is going to be the hard part. Once we get the cable tacked down, we're good to go. It's going to be easy. So I'm going to grab this. Again, some overlap here. And it's about 6 p.m. and I haven't eaten anything all day, so that is why I'm shaking, but we're going to pull this off. I want to create a solder bridge here and here. Sometimes it could be a little bit tricky, but there we go. We have it, and that is sufficiently aligned as well. Now from this part out, it's going to be relatively easy. So let's just zoom in. Let's make sure our alignment is good. And it is. It doesn't have to be exact, but it's got to be close, and that is pretty darn close for freehanding it like that with shaky hands. So we're good to go. So same thing here. I'm going to bridge on this side, so we have 2 points. And sometimes it helps to pinch the cable with your tweezers gently. Just like that. There. That's done. And now we could reinforce our joint on this side as well. Now this is just going to serve to give us some support. We are going to run individual wires on each of these pins except for the LED returns. We'll get into that in a second here. If you notice you don't want to bridge, you have to add more solder. So if it doesn't want to immediately bridge, just got to add a little bit more solder there. There you go. So that is done. We're connected on both sides. We're good to go. Let's talk about these lines here. Okay. We have 6 little traces here. As you can see, we have 1, 2, 3, 4, 5, and 6. These are LED return lines, and they correlate with the amount of LED strips in the screen. So these are mainly used for current sensing purposes, and believe it or not, we don't need to run wires for all 6 of these. What we can do is run a big wire loop combining all of these. Now that is kind of better for a couple of reasons. One, okay, if we have multiple wires there and for whatever reason a trace breaks, okay, you'll have a portion of your screen that's out. Okay, that's not going to happen if we have all of these combined. It's not going to be detrimental to the performance of the screen. It's not going to be detrimental to backlight or screen colors and anything. So how we do these is we combine all of these together. You could run individual wires across these. It's totally up to you, but you can also just combine all of these together. So you could do it both methods. It's not, one method isn't really inferior to the other, just to put that out there. So either way works, honestly. You shouldn't consider one method better or worse than the others. So I'm going to start by one wire across here. And I guess just for the sake of this video, I'll do the 6 wires across here. Again, a tip is it's not necessary. You could just make a wire loop. I'll leave it up to you to decide what you want to do. Again, either method is not inferior to the other. I usually do a loop, but a loop is not inferior to wires, and wires are not inferior to a loop. So we just need to gently get this guy down here. Patience is the key with this. There. It's fine that it's bridged. We just wanted to get it down there. Now I have control over it. There's that. Now, a little bit more flux here. You want to make sure your solder joints are solid. Okay, so you shouldn't have parts of the wire that are sticking up, not connected. They should be solid. And to remove this wire, we're going to gently twist this like this. We're dealing with something very delicate, so we got to be careful. All right, just like that. If for whatever reason you see your cable lose, the solder joint lifts up after you twist, you will have to redo that. Okay, see this? See how it's pulling up? All right, that's your key to stop. Get your iron, reinforce your joint. All right, pulled off most of it there. Got to do it again. And you will notice a lot of times it will want to pull that wire with it, so don't get frustrated. And that's one of the ways that I kind of do like doing a loop more than this, because with the loop we only have to do this twice. But again, this is just part of the process. This is part of what soldering jumper wires is. And it also helps to secure your cable. So I have a little piece of double back tape here. You could use Captain tape too, so there's just double back tape here for when I have my T-con board up there earlier when I was showing you guys. So you could use double back tape, Captain tape, whatever. Just going to position this here, press it down, and that's fine. Continuing. And there's that, it came off. So we are going to repeat this process for every one of these little wires here. So 1, 2, 3, 4, 5 left. This is separate, so we don't have to worry about that, and we'll take care of that one in a minute here. So let's continue on. And if this is your first time soldering, don't do this. I should point that out. So if this is your device and you think you're going to be able to do this and you've never touched a soldering iron before, don't do it. You're going to end up screwing something up. This is mainly geared towards people that either customers that want to know what's going on with their device, or to people that already solder that want to know how to fix this. There's that. I need a little bit more solder on that trace. And I don't want this sticking up either right here. There, that's good. Same thing, hold it at the base, close you can get to the base. Circular motion. And it's off. I'm gonna put a little bit more solder on that, or just touch it. Just like that. Come on. Wants to be stubborn, so I'll do this side first, I guess. My iron wants to stick to my iron. Gotta clean our tip off a little bit there. There. This is definitely something you just need to sit down and do while you're relaxed, because this is, especially with all the little wires, this is something that definitely requires some level of patience. And there's 3 more to go. In this case, I don't like the looks of my wire right here, so I don't want to use this one section of wire. So I'm just gonna put him up here. We're gonna not worry about it. I don't want wire that has loops in it or anything, which happens when we're twisting it, because that wire could be fatigued and it's not gonna last. And that's not what I want. There's that. And I'm just going to touch up the joints after I'm done twisting, just to make sure, because sometimes our eyes miss stuff. I just want to make sure that it's absolutely perfect. It's good to go. And now for our last 2 here. And technically a bridge like that is totally fine on these return lines, so I'm just actually going to leave that because that's not going to hurt anything. And another reason why I'm leaving this and deciding to leave this is if you saw before we bridged it, there was an area on those return lines that in that on that cable that it was kind of like pushed downward a little bit, just where the natural curvature of the cable was pushed downward. And having a bridge here would actually provide a little bit more strength in that area and reduce the chances of this solder joint breaking. So that's totally fine to do that. Yeah, it's totally fine. We could even do this with every single one, and it's not going to affect it. And I'll show you that it's not going to affect it. If I can get a bridge. Oh well. We have two with a bridge. That's fine. So not going to hurt anything. Don't sweat it if you bridge something like that. Like I said, it's no different than doing the loop method. Totally fine to do. Not going to hurt anything. And like I said, it can even be beneficial in some ways. So don't sweat if you bridge return lines. Of course, there's probably some electronics engineer out there that's losing his mind, but we're not going to worry about what he says or thinks. Because from a practicality standpoint, this is totally fine. So what might actually happen, let's say you lose an LED return strip. Well, what might happen if you lose an LED return strip altogether, you'll get stage light effect, or you won't have backlight at all, depending on how it fails. With the return lines combined, you'll just get stage light effect instead of no display at all. So it's not nothing critical. As long as there's LED return lines present, as long as it needs to loop back. So basically, the LED return lines are used for two reasons. One is to kind of have the backlight driver know that they're there and know that they're using current. And the second LED return line is just to complete the second purpose and the most important purpose of the LED return line is just to complete the circuit, as it says return. It's basically completing the circuit from the LED strip on the screen back to the system board. So that's where that comes from. As long as it can complete the circuit, you're totally fine. Now this one's going to be a little bit trickier because I have to work within this tiny space. Come on, go where I want you to go. I'm going to switch to a smaller tip just because that small thin space is going to be pretty hard to work in with my BC50. There's that. I like my BC50 better because it holds more solder on the tip, but the conical ILS tip, the small one, is perfectly fine for this as well. Totally fine and bridged again. Again, I don't care. I'm not going to waste my time fixing that because it's not necessary. I care that it completes a circuit, and I care that the backlight driver is able to tell something is there. That's all I care about. It doesn't, like I said, it doesn't affect functionality. It doesn't affect safety. You're totally fine. Come on, little wire. I see you. What will affect safety is if this touches ground when it's on. That's why we're going to get rid of him. And now, if you don't know how small this wire is, This is about the size of one of my hairs. So this is about the size of a human hair. Just to put in perspective. It might be a little bit bigger, but it's roughly the size of a human hair. So that's pretty small. There, he is off. Get out of here. Okay, there's that. Now what we need to do is we need to run a wire for backlight. Our actual backlight line. There's that. Just make sure everything looks good and connected, and it does. It looks pretty good. No bridge. Yep, looks good. All right, so here, this thin one, we have another ground here. Okay, there's a ground there, and then here's our backlight line. We don't need to run a wire on this one because this is just, again, this is just ground. We don't have to worry about it. This is the one we have to worry about because this is actually our backlight line. So what we're going to do is run a wire across that one next. So one very important thing you'll notice is this trace is a bit larger than the other ones, and that's because it handles more power. This is our main backlight line. So we aren't going to be able to use that thin wire. We have to use a thicker wire for this. So I'm going to use my enamel coated 37 gauge wire, which is substantially bigger, as you can see here. So this, we're going to run this across there. I'm going to scrape away my enamel coating first. So I'm just going to move my wire over here. Scrape this coating off. A little bit of flux helps too. Of course that was off a frame. Anytime you try and show something important, it's always off frame. That's what happens when you work under a microscope. Get used to it. A little bit of flux. And that is good. So this is like our main line here. This is like our aorta. This is the lifeline for our backlight circuit. This is the backlight wire. This is the backlight line. There's that side. We're going to need more solder on that, so don't panic just yet. We're going to put more solder there. And there's that. Now it's time to flood this. I want a nice thick layer of solder on this. Just like that, just like that. Beautiful. That's exactly how I want it. So that's perfect. That's absolutely textbook perfect here. Let's get this cable off, and now the last step is to put two supporting wires across our ground planes there, which are those two massive traces, and that's going to provide structural stability to the cable. There's that. Nothing on this side. Good. Same thing. We're just going to scrape away our excess on the cable. Really easy and simple. This gives the other opportunity to show what I'm doing when before it was cut off. Okay, we're just scraping it. Gonna need enough for two sides, so just like that. That should be sufficient there. We might have to get a little bit more. Now notice how our solder is not melting as easy. That's because this smaller tip doesn't carry as much heat as the BC50. It's still going to work totally fine, but we'll just have to heat soak it for a little bit longer. Flux. Now picture this wire as a kind of like rebar. It's kind of holding the concrete in place or holding the solder in place. Just like that. Beautiful. We'll do one for the other side as well. This one is a little bit thinner. Once I get it down there, I could use my tweezers so I don't burn myself. Just like that. We're done. So now we don't want to just put this back in the machine like it is. We got to clean this up, and then we got to coat this. Now we use two types of conformal coating here. We used to use this other rubberized stuff, but we have since stopped using it because it had some magnetic particles in it. I wasn't sure what was in there. It worked totally fine. It wasn't conductive, but I didn't like the fact that it did have some iron particles in it. I'm not a chemist. I can't tell you why conformal coating like that would have iron particles in it, but we didn't like it, so we're not using that anymore. Now, I should say that it was totally non-conductive, and there was no harm to devices that were using that. We just made a choice to discontinue use of it. Thermal paste, on the other hand, is widely praised as non-conductive as well, yet thermal paste has all kinds of metallic particles in it, so nothing to really worry about. We're just going to clean this up. Now you'll notice here I could feel some wires sticking up, and there's a little bit of excess there. Now these guys are bad. We got to get rid of him. Anything that's sticking up has to go. It looks like just one that we missed, so gentle back and forth. And there's that. Because I don't want that folding over and puncturing the cable down the line or anything like that. So I'm just cleaning this with isopropanol, and then I'm going to go back with acetone as well. But for right now, isopropanol only until I get most of this off. So now I'm using the dry side of it, and now I could use acetone. We don't want any residual flux in there when we're putting conformal coating on, so we want to get this as clean as physically possible. So there's that. I'm actually going to lift this up now and clean on the other side, because there's going to be some flux hiding on the other side, so we got to get rid of that. It's not going to be a whole lot, but still, again, clean as possible. Don't really want to use isopropanol on that plastic layer on the screen because it will eat it away. So back to isopropanol. I don't know if I said acetone or isopropanol. Acetone is what we don't want to use on this plastic layer of the screen. And once we know it's sufficiently cleaned, we can go ahead with our first layer of conformal coating, which is going to be a green UV coating. The green, there is a difference between the green and the black, I learned. So the black is a little bit thicker and it doesn't penetrate as well with light. So green will let more UV light through and cure a little bit quicker than the black, but the black is going to be our final coating on top to make it look factory and to provide some additional structural support. So this is a very strong cable. You could already tell it's pretty strong there. Just going to double check any potential issues, and everything looks pretty good. Don't see anything of concern here. So I am going to go ahead and actually look at this. So this is why I always say double, triple check stuff. Little nub here. You get out of there. And that's fine like that. Anyway, this is good. There is a very minimal amount of flux. It's not going to cause an issue here. So I am going to start by applying a thin layer of the green UV coating here. So here is our UV coating. I'm just going to put a drop here. I'm going to spread it out. So that should be sufficient. Might end up needing a little bit more. I'm just going to spread this across all. Yeah, I want a little bit more, especially right here. Anywhere that's exposed on the cable, I want a thin layer of this stuff. We're going to do 2 layers of this and 1 layer of the black. All right, there's that. Let's go ahead and grab our UV light. And we're going to let this cure for about a minute, which is going to be off camera, because I probably wouldn't want to be blinded, and I'm going to guess you guys don't want to be blinded either. But here we go. Alright, we're done from UV curing on the first layer. Let's just double check this is actually cured. And it is indeed hardened. So we are good to go with our second layer. So this layer I'm going to make a little bit thicker. Alright, now we're going to spread this out again. We don't want it too thick because then it won't cure, but I do want the thickness there to make the cable a little bit stronger. Okay, that's good. Back to UV curing. Okay, second layer's on. This one's a little bit thicker, so we got to make extra sure it's cured, and it is. See how it's not pushing down or gushing out or anything, so this is cured. Finally, this is our last layer. This is mainly the final layer, largely cosmetic, but some structural support as well. This is the black coating. This is a black flex cable, as you can see. So this is actually a little bit denser of coating, so it does add some structural support, but it would actually, the cable would actually be perfectly fine if I were to just leave it like it is right now. But I want it to look nice and pretty and OEM. start with that and we'll fill this in. Kind of get this spread out a little bit. I'll go in with my tweezers again. Now this layer does take the longest to cure as well, so that's something to take in consideration. Notice how it is not translucent when the green was kind of translucent. This is not at all translucent. And that also means light will not penetrate it as easily. There's that. This little area filled in. There we go. All right, now back to conformal coating, and then we'll have our finished product here. We can test. Not conformal coating, but UV curing, I should say. So turn on the blinder again. All right, this is definitely sufficient on the conformal coat now. That is relatively solid. Still, the black stuff isn't as solid as the green stuff, but that is good to go. So let's go ahead and get this back in the enclosure and see if it works. So let's pull this off. Let's just show the finished product here. So we have to plug this back in the screen. So we are going to wrap this around like this and then plug it in right here. So you can see the cable is much longer and it's going to be a lot less prone to having that FlexGate fault in the future. So we just want to plug it into that FPC there and we are good to go. So let's look at the screen on our other camera. So here we go. So here is our fresh new flex cable. From a distance it looks pretty much brand new. You can't even really tell that it's been spliced, but that is good to go. Let's go ahead and put this back in the enclosure and let's see if this device works. Okay, now let's take a look and see what has changed with the behavior of this cable when the screen is opened and closed. So look at this now. Notice how there's a lot of excess cable here. Now if we look at this, this is not kinked. There is plenty of leeway here. It's a nice loop. So it's instead of being kinked, there's a nice loop of cable here that's under not a lot of stress. So let's look at what it does when we open the device fully now. So what you'll notice, let me position the device over here so I can swing my scope around. So look at this. I'm opening the screen and the cable is minimally moving there, but what is moving is back and forth. My scope just will not focus today. I don't know what is up. So look at this. So it's sliding back and forth right here, which is the strongest part of the cable, sliding back and forth, right? So if it is going to wear, it's going to wear into the backside tape on that flex cable that's there from the factory, or the conformal coating. That's why we do 3 layers. But we'll notice here, the part that fails, it does not even move anymore. It's all replaced by sliding action. So let's go ahead and power this on. I'm going to plug in my screen connector, plug in our charger, and let's see if this gets backlight and retains backlight when we open the lid fully. Alright, so if you remember before, it would instantly lose backlight if the screen was opened slightly. So I'll just do that just to keep it consistent here. We'll do it this way, around 45 degrees, right? Wait for it, wait for us to see an Apple logo in here. Battery's unplugged, by the way. We have trackpad click, just waiting for it to boot. There, that is an Apple logo. Can't see it in there. There we go. All right, see we have backlight now? Look at that. Bingo. All the way. Retained full brightness. Okay, we can do this as much as we want. It's not going to hurt the screen anymore. So that is fixed. This is how we do this repair. And that's how it's done. So thank you for watching, and I hope if you're another technician, you want to do FlexGate repair, this video helps you in some way to figure out how to do that. So thank you for watching again, and I'll see you in the next video.